Yeah, my name's Liam Farrelly. I'm an architect with Tallon Walker, and I was design team BIM lead and project information manager for the design stage of Trinity. So most of you are probably familiar with the REBA's BIM overlay to the plan of work, which was released in 2012. But the reason I put that up there is, so technically in relation to public works contract, there's no direct comparison as of yet. Plus, as Michael mentioned earlier, the CIC BIM protocol, the new one was released yesterday, which helped deal with a lot of the issues, but in a public works contract sense, that's not really any use because we can't amend or append the public works contracts. That's not to say BIM can't work, of course it can, but perhaps if there was more mention of BIM in the actual contract, that it might help alleviate some of the issues. So I'm going to talk about three stages today, mostly detailed design and tender stage, just one or 2 points on concept stage, and then a bit about construction, which Celine will probably be focusing on more. So yeah, firstly, concept design stage. As Michael talked about earlier, I'm going to talk about the survey. So the site is in the northeast corner of Trinity's campus. The reason I put that there is you can kind of see the complex nature of the site. There's a lot of different geometries going on. So the only real way to survey this site was get a laser scan carried out, because we had exclusion zones in relation to the dart track. We had existing buildings, existing paths that we all had to keep clear of. So 3D was the only way to do this. So we got a laser scan carried out of the entire site. There was also 6 protected structures on the site, so it was useful to have a digital record of those. So for example, if we ever needed to go back and measure the exact cornice width that was there, the detail, we have a physical record of that building at a moment in time. So the benefits of that are obvious, really. That was everything in grey is the survey model that was provided. So it's a great tool, great design tool to work from. You immediately you can take whatever section you want, because if we had got a surveyor to do as many sections as we want, it would have been an infinite amount to accurately describe each of the boundary conditions. So when we have 3D, we can make up our own drawings and decide what sections are best for us, or drawings. So that was extremely useful at the outset. Plus, point clouds tend to be quite interoperable with BIM software. We were using Revit, so although we were provided with the model, we were also provided with the point clouds. So if you're ever doubtful over the accuracy of the model, you can go in and measure from the point cloud yourself to verify the surveyor's information. So brief summary of that stage. Yeah, surveys are great. Or laser scans. Live areas, again, because we had such a detailed brief from the client, it was very useful to have a 3D model with live areas that update as we change and develop our model. So costing, again, if you have live areas. Challenges, this was the early design stage, you're not really collaborating too much with the rest of the design team, so there's no real major challenges at the early design stage. So moving into the meatier part of this presentation, detail design and tender stage. So as Michael alluded to earlier, we were working to a tight program in this project, so the detail design and tender stage was quite tight, so it was fundamental that we were extremely efficient in this process, which BIM certainly helped. So yeah, as we're developing the model, I suppose, to get to the detail design stage, there's a lot of information in the model, and obviously you have to be coordinated with the rest of your design team, but you also have to be coordinated with your own work. So if we're taking door schedules from our model, we know that schedule is an exact representation of the drawings. So to have a single source of information that you can take all your drawings and schedules and specifications somewhat from is extremely useful, because it saves time checking your own work when you really should be focusing on coordinating your design with the rest of the design team, the structural model and the M&E model. So one of the main advantages we saw at this stage is document control. It comes back to the single source of information again, but I suppose the level 2 naming convention that most of you are probably familiar with is relatively complex. So to have the software to be able to manage all that for you, and to automatically be able to batch print all your drawings in a few hours without having to sit at your computer. So I think we had something like 660 drawings for tender, so we have to update every single one of those title blocks and issue all those drawings. So with the BIM software, we were able to just update all the title blocks in a few minutes and set all the drawings, print them, and come in the next morning, and they're all ready there to issue for tender. So that saved us days and days of work, and it's probably saved us weeks of work during the construction stage, just constantly being able to automatically control your issue of drawings, and you'll be able to automatically name them and batch create them. It just saves so much time. To be honest, that alone is worth using BIM for. So clash detection, a lot of people, this has been talked about quite a bit. I suppose what we found was during the early design stage, there is software for automated clash detection, but I suppose at the design stage and detailed design stage, that wasn't really that useful to us, because I suppose the models are constantly in the state of flux. You're still designing the building, moving walls and stuff, so we had something like 10,000 clashes when we ran the first run of the automated software. So we came up with a system of visual clash detection where we check the floor voids, check the ceiling voids, check the areas of the buildings that were structurally more complex. So, and it was a much better system that we worked with Adrian in ARCS, and it was just a much more efficient system, and we came up with a log that I suppose Adrian can talk about more in his presentation. The other thing, I mentioned there is this was modelling. If you're modelling for clash detection, the people who are modelling, this is probably going to come up a few times, need to have a good construction knowledge. So if you're modelling a pipe, let's say, you need to know that insulation needs to go on that pipe, it's a rainwater pipe. So all of that information needs to be in the model. So the people who are modelling need to have a good construction knowledge, and it can't be, I don't know, someone who's potentially straight out of college and knows how to use Revit but mightn't have a good construction knowledge. If they're building your construction details, then you could potentially run into problems. So this is probably the most important slide in the presentation, is what is the purpose of the model? And this question should be defined at the outset, but should also be redefined throughout the tender period, or tender and construction period if needs be. So this was, we were lucky enough there, our brief from the client was quite detailed. They said, well, they wanted the model to be used for service coordination, used for costing, used for visualization. So we knew at the outset how much detail we had to put in the model. Because all of those categories at the top, service coordination, costing, visualization, they depend how much work we essentially have to do, and we need to be paid for that work if we're doing it. So for BIM to be efficient, you really have to be doing the minimum amount of work to suit the requirements of the project. So if we're only modelling for service coordination and we're not costing from the model, if we're putting all this extra information into the model that nobody's ever going to use, it's not going to be an efficient process. So the purpose, you need to be efficient, and I suppose that's one of the problems that people say with the construction industry in general, is that we're one of the least efficient industries. So you really need this to keep asking yourself throughout the project, what is the purpose of this model? And if it's worth modelling it, or will I just issue a drawing in 2D? So our rule is if someone's doing clash detection, yes, you need to model it. It needs to be set out, but if it's just a standalone detail and it's just going to add extra bulk and information to a model that's already quite heavy, there's no point in modelling it. Perhaps just issue a 2D drawing of it. So these 3 points are kind of linked to costing of the model, and so this was kind of a learning process for us, because I think the software at the time was only just released, so we were developing this for our QS. So because they were costing from the model, we had to work to a much higher standard. So we had to make sure that everything was named properly in the model, and I suppose the biggest risk with this is when stuff is downloaded. For example, you're looking for a door, we'll say, and you download the Rolls-Royce of a door from the internet, and you put that into your model when in fact you're only specifying a Fiat Punto door, we'll call it. But if that information is in your model, somebody can use that information and go, oh, well, they've spec'd this really high door, and you're like, oh, well, I just downloaded that, and that's not really what it is. So you need to be really careful with what's named in the model. So yeah, these 3 points, the accuracy, the costing, depends on the quality of the model. So that's pretty obvious, but the quality of the model is really the quality of the information, as I just said. So is everything named properly? If a plasterboard partition has a fireboard on it, is it called that, or is it called basic board? So it's kind of the technical information that you put into that model has to be accurate. And then that comes back to the point of who is putting that information into the model. That person needs to be competent, needs to have construction knowledge of how things are going to be built. So the last point in bold, back to the point of being efficient. The purpose of BIM on this project anyway was not to build a one-to-one model of the entire building and make sure that every single detail in that building is perfect. Because ultimately the contract is based on drawings, we're building from drawings, we're not building from the model per se. So if we spent our time checking every single skirting detail, every single to make sure it was perfect in the building, we'd be wasting the client's money and we wouldn't have enough time. So this comes back to the point of we need to define the purpose of the model, and everybody needs to be working to that purpose for the process to be efficient. So yeah, further point, just costing from the model, kind of general point on marketing hype and expectations. I suppose our QS was very excited about the prospect of costing from the model. They could get areas very quickly, they could get lengths very quickly, but Expectations need to be managed, or they may become unrealistic, like 3 smiling QSs in the corner. Okay, I suppose BIM and the contract, as I kind of mentioned before, the contract really isn't set up for BIM. It's not saying it's impossible. BIM, of course, works in the contract, but there could be perhaps more done with the contract. BIM isn't mentioned in the contract anywhere, so and it can't because you can't amend it. So perhaps there is a way of amending it, or something could be done. If we could append the CIC BIM protocol to it, it might work better. So one example of this is just M&E tend to be tendered as reserve specialists. So they don't submit their tender until the main contractor has been identified. So they're naturally working to this later deadline. So as we're coming up to tender and we're kind of trying to get our drawings out with our coordinated M&E model, and yes, they're helping us as much as they can, but ultimately their deadline was 2 or 3 weeks after us. So if they're working to a different deadline than the rest of the design team, there's going to be issues with the models, which I suppose comes back to the EIR. That's another thing. The EIR defined at the outset the employer's information requirements. Back to what is the purpose of the model. This comes back to what level of detail you're modelling to. I suppose most of you are familiar with this kind of slide, and there's various definitions of level of detail, level of model definition, levels of information. There's all these different definitions, but essentially they're all too vague. And the images that are attached, because if you're sitting in a meeting with your contractor and you're trying to say our model's level 3, look at that postage stamp there, can't you see it's obvious? You know, you're going to have a difficult argument with them. So there needs to be more universally accepted standards of what standard of model should be at tender stage for the handover, because handover of model seems to be an issue on a number of projects. It's just that stage of who owns the model after you hand it over and what standard the model should be at when you hand it over. So yeah, lessons learned that stage. Yeah, great tool for generating drawings, document management tool, excellent. Visual clash detection, we found that worked much better when you're still kind of designing the building and moving it around. Can't cheat the model. Yeah, a lot of issues were highlighted in 3D, which is great. Regular upload schedule, yeah, we had that with our rest of the design team. Costing process, yeah, really speed it up, but again, expectations need to be managed. You need to sit down with your QS and go, you can take this information from the model, but you can't take the other. Because we tend to, when we're issuing a tender, we'd issue all our ceilings in one go, then we'd issue all our partitions in one go. But when you're issuing a model with that, you go, okay, here's the model, but only use that for the ceilings because we're still working on the partitions. So that it doesn't really work, because that model will get handed off to someone else who won't have heard that advice. So I'm not sure what the best way to manage that is. We kind of put a cover page on our model, so whoever opened the model could immediately see what information they were able to take from the model. So challenges, as I said, models at an infinite scale. We can't model every single detail in the building because we're not 3D printing it yet. Model's always in a state of flux, yes, so it's always developing and moving. So the quality of information isn't uniform in the model. BEP, EIR, as Michael kind of alluded to, is standard templates available. So construction stage, I suppose Celine will be mostly focusing on this, but just want to add 1 or 2 points. So yes, these are all our federated models, and we're using software that allows us to view the model in the cloud, but the most useful thing for us to date has probably been the subcontractor submissions that we have been given a model for. So there's quite a lot of steel work in the building. There's 4 or 5-story atrium, and all the roof is steel. So there's quite a lot of steel in the building, and we had to check the set out of that to make sure it was all perfect. But the submission we got was whatever 10-15 drawings of structural details, which most of the stuff was irrelevant to us. So we're looking through all these drawings trying to make sure it's set out correctly. But at the end of the day, we were checking the drawings obviously, but we had the model, which was much easier to check, and sure enough there was a few clashes that we were able to pick up with sloping beams that weren't actually shown on the drawings properly. So it's just a much better tool, and it's saving clashes on site for definite. So just a quick summary of that stage. Yeah, coordination is great. To be honest, we've had very little requests for ceilings to be dropped or clashes. There've been very little M&E clashes on this project. I suppose it's a naturally ventilated building, so the M&E mechanical services are quite light in that regard, but in general the M&E coordination has been working well because we haven't had to redesign anything significantly because of an M&E clash. Subcontractor models, yes, steelwork was great to get that. Less correspondence, yeah, as I was just saying, we've got less phone calls going, can you move this, can you move that, because it's all been coordinated well in advance of getting to site. Challenges, I suppose, yeah, a few points here. Models are contract documents. We tend to not issue our models as a contract document because if we can, because fundamentally we're saying you cannot build from the model yet. Because as I was saying, we're not paid to build a perfect model that somebody doesn't need drawings for, and I don't think the industry is at that point yet. So we issue a model for information to assist the contractor to build from that. All our drawings are taken from the model, but the drawings need to be read in conjunction with the model. And the model, I suppose, it's a representation tool. Every single detail in that is not 100% perfect. I think that's a point to get across. So next point, saying model for information versus contract document. Can we build from the model? So yes and no. Like, we're all working to the set out and dimensions in the model, but ultimately, you're not fundamentally building from the model. If someone, as I said, zooms into a corner of one building and sees the skirting is missing off that bit of wall and goes, oh, well, I didn't put it in because it's not in your model. Like, that's why we have drawings, because it's much easier to check one typical detailed drawing than check an entire model. Ownership of model, that's a kind of an issue. I know Celine will have a few words to say about that, as well as who owns the model. We hand the model over to the contractor, but if the client makes a significant change or design team oriented change, we have to update that model and then give that back to them. So there's a bit of disconnect there. So fundamentally what I'm saying is, if we can move away from image on the left to more on the right, I think we've on Trinity BIM's worked quite well, but that's because we've had a good working relationship with the contractor and we're all willing to work together to achieve our goals. Okay, thank you.